So another important operation on matrices is that of taking the transpose of a matrix. So this would be easiest to understand with an example. So let's let A equal 1, 3, 4, 2, -5, 0. Okay? Just a pretty arbitrary 3 by 2 matrix. To take the transpose, we notate it by a t where we would normally put an exponent. So the transpose of A is, so A transpose. So that is, we're going to take the transpose of this matrix here. The transpose is very simple. We just swap the roles of the rows and the columns. So 1, 3, 4, 2, -5, 0. Okay, so note what happened here. What was my first row became my first column. My second row became my second column. My third row became my third column. And also, the columns became the rows. My first column became my first row. My second column became my second row. Okay, so we're just swapping the role of the rows and the columns. Let's write this up as a formal definition. So we're starting with the matrix A, and it has components Aij. Okay, so that, remember, that means we're thinking about the ith row and the jth column. This is the component in the ith row and the jth column. This is going to be an m by n matrix, so m rows, n columns. Then the transpose of A, denoted by A to the t, would be an n by m matrix, because we're switching the rows and the columns. The number of columns we had is now the number of rows we have. The number of rows we originally had is now the number of columns our transpose has. Okay, so the transpose matrix, every element Aij is now the element Aji. Okay, that is the same element that was in row I and column J is now in row J and column I. Okay, so the column became the row became the column.